Hi everyone, so for today's lesson, we are starting a new topic which is called as momentum. Alright, so as you can see 4.3, so which means it's the third chapter under Cambridge syllabus, but it's actually our fourth chapter. So if you can recall, the first topic that we learned is kinematics of motion in straight line, right? So we learn about Subart formula, then we learn about the variable acceleration. Then after that, the second topic that we discussed was forces and equilibrium. Okay, so we learned about how do you calculate the resultant force, then how do you calculate some forces if let's say the object is in equilibrium as if there's no acceleration involved, so whether it's at rest or it's moving with a constant velocity. Okay, then the third one which we just finished is called as the Newton's law of motion. Okay, so today's we are actually in the fourth chapter, and this chapter is actually very short. So the learning, there are only two learning outcome for this chapter, and we are going to finish it within two lessons. So which mean today's lesson and also Wednesday lesson. So if you are M1, then which means it will be Friday's lesson and then Monday's lesson. Okay, then we're going to complete this. Then we can move on to the last chapter, which we will be discussing for the part of work, energy, and also power. Okay, so for today's lesson, we are going to look at what is the definition of momentum and then understand it from its vector nature. All right. So something to bear in mind is that for all the momentum questions that we are going to solve is about the motion in one dimension only. So you are not going to do any resolving here. So which means the motion that we are talking about is just like whether go to left hand side, go to right hand side for a for a horizontal direction, or in the other case, then it will be up down. Okay, so that's the idea of it. So something that you will realize is that it will be very difficult for you to find a past year question for momentum because it's actually a new syllabus starting 2020. So that's why you can only find this question in the 2020 past year paper. All right, okay, so let's start with the introduction. All right, let's start with what is that meant by momentum. So momentum can be defined as the mass in motion. Okay, so which means that momentum tells us what is the amount of motion in an object with a certain mass. So we know that every object has its own mass, right? So that's why every moving object will have this momentum. Okay, so a body of m kg moving with speed v meter per second has momentum p. So momentum is denoted by the symbol p, and the formula of momentum is just p equal to mv. Okay, so which the m is the mass of the object, then the v is the velocity. So in this case, they try to write speed because it's the magnitude. So later we are going to talk about the vector nature of it. So the unit of the momentum is actually Newton second. So you might be wondering like, why is that Newton second? Okay, so that's the idea. So you see, right? We know that P is equals to mv. So what is the unit for m and v? So m is the mass, right? So that's why it's kg. So velocity is actually meter per second. So what we are trying to do here is to split this. So which means that what we get is like kg, then after that meter second square. Okay, so if we are doing meter per second square, then what happened here is we actually multiply an s, right? So this is what we do so that we get back to ms meter per second. So what is this become? This is actually m. Then what is this? Acceleration, right? Then after that, s is just our time here. So which is, I'm just writing my s here. Okay, so this is time. Okay, so now what do you realize? What is ma? So from what we have learned previously from Newton's second law of motion, we know that mass multiply acceleration is basically the force, right? So that's why you can get the force and the time. So what is the unit for force? It's actually Newton. Then the time is second. So that's why at the end we can get that the unit for momentum is actually Newton second. Okay, so momentum is a vector quantity, so it will has the same direction as the velocity. So that's why when you try to answer the question later, it's very, very important for us to denote that where is our positive direction, because it will actually give you a different answer, especially we are trying to calculate the change in the momentum. Okay, so this is what I have mentioned just now. So all questions in this syllabus will be on one dimension only. Okay, so I'm not going to deal with like anything more than one dimension. Okay, so let's try to look at this very simple example and we try to find out what's the momentum. So we know that P is equals to mv, right? So that's why for this baseball, the mass is 150. So which means that is 0.15, and then multiply is velocity, which is 45. Okay, so from here, what we can get is 0.15 times 45, right? So we are able to get this 6.75 Newton second. Okay, so what's the momentum of this moving elephant? So you will realize that if let's say the object is not moving, then it's not going to be any momentum because the v will eventually be zero, right? So when you times your velocity, which is zero, to the mass, then at the end you will still get momentum equals to zero. So you can imagine as if it's like the impact that you have. So if let's say the thing has it's not moving, right? For example, you can try to imagine when you collide with a moving elephant and with a non-moving elephant. So the impact that you have is eventually going to be different. Okay, so that's the idea. So for this case, then the momentum that we have is the mass, so it's 5 tons, so that's why it's 5,000. Okay, multiplied by the velocity, so we can get 20,000 Newton second. Okay, so how about this train? So it's 7,000, and then we need to multiply 1,000, right? Then after that, how are we going to change this velocity to meter per second? So this is km per hour. So which means from km to meter is 1,000. Then from hour to second, it will be 60 times 60, right? 60 minutes, then 60, each minute you have 60 seconds. So that's why when you try to change it, then we'll be able to get 1555585. 78.6 Newton per second. Okay, so as what you can see here, right, the momentum is actually directly proportional to object mass and also its velocity. So which means the higher mass that at so which means the greater the mass of an object, the momentum that you will create is actually greater. So for example, when we try to compare to the baseball and the elephant, so you'll realize that actually this baseball is moving with a higher velocity, right? So compared to 45 and then 4. But then because of the mass of the elephant is actually greater than the baseball, so that's why the momentum that you're trying to create here is actually bigger than the baseball. Okay, then the other thing is also when we talk about the velocity, so which means if let's say you have a very light object, which means you will need to have a very high velocity, so to have a same momentum with an object that's with an heavier mass. Okay, so that's the idea. So you can always imagine momentum in a way that momentum tells us how much effort you need to actually stop an object from moving. So you can imagine if let's say someone is trying to throw a baseball to you, either with a very low speed or with a very high speed. So which one do you think that you need more effort to actually stop the object to actually catch the ball? Then obviously it's the one that moving with a higher velocity, right? So that's why the momentum is actually higher. Okay, so in that sense, then when you compare to the mass, so maybe it's a very, when we compare a baseball that travel in a very low speed, then the speed is actually the same with the speed of the elephant is moving, but because of the mass of the elephant is actually much more bigger, so it's harder for you to stop the elephant than the baseball. Okay, so you can just understand as if the momentum is actually depends on two factors lah. The first one is the mass, the second one is velocity. So the greater the momentum, which means that it will be harder for you to stop the object. Okay, so I hope that you can have a good idea on what momentum is. Then for an object that moving with an initial velocity u and final velocity of v, so the change in momentum, it will be the final velocity, right? When we try to find the change, which means we'll always use the final momentum to minus off the initial momentum. So let's try to write down. So final momentum, then minus off the initial momentum. Okay, so for the final stage, we actually have an final velocity of u. So that's why the mass is m, then v, correct? Then minus off the initial momentum, so the mass multiply the initial velocity, which is u. So you can realize that you are going to use this mv and mu's a lot later. So if let's say you think that's much more helpful, then what you can try to do is normally we try to talk about an object with the mass is not going to change, right? So that's why the same object is having the same mass. So that's why we can always try to factorize it to mass. Then after that, we left with final velocity minus initial velocity. Okay, so that's pretty much the part for introduction. It's actually very short because it's the first lesson. So it's just for you to understand what momentum is, and we try to solve some question here. Okay, so you can see that there's 8 questions. So for the first 3 questions, we are going to talk about for the first 3 questions, like 1, 2, 3. We're just going to talk about the very normal thing, which is how to find the momentum, how to find the change in momentum. So 4 is about a bit of your kinematics, but you are not going to use any formula about kinematics yet. Then number 5 and number 6 is about, 5, 6, 7 is about Suvat and also momentum. Okay, so you're going to use your Suvat formula to help you to solve some momentum questions. And number 8 is on variable acceleration. Okay, so let's start with the example. Okay, example 1, a particle of mass 4 kg has an initial velocity of 5 meter per second. Find the momentum of the particle. So it's very straightforward, right? So it's just P equals to mv. So let's substitute the mass, which is 4 kg, velocity 5 meter per second, and we can get our answer is 20 Newton second. Okay, so for B, find the magnitude of the change in momentum if the velocity of the particle increases to 12 meter per second. So in this question, we try to assume that there's no change in direction involved. Okay, so P will be equal to mv, the final momentum, minus of the initial momentum. Okay, then after that, for mass, as the mass, then after that, we can try to do the factorized one. So 12 minus of 5. So depends on you. Like if let's say you are writing like 4, 12 minus of 4, 5, also it doesn't matter. You'll actually just get the same answer after that. So 4 times 7. So from here, then I'll be able to get 28 Newton second. Okay. So just to give you an idea, right, when we talk about the change in momentum, we always trying to focus, we try to indicate the change of momentum in that particular moment. So the idea here is that you realize that the question actually didn't give you like the velocity of the change, right? It may take like 5 seconds, it may take like 2 seconds and so on. So we doesn't know whether for example, the time change, isn't it like when t equals to 0, then the velocity is actually 5. After that, when t equals to 1, it's actually going to be 8 first. Then after that, we go to like 13 and so on. Okay, so we are not taking into consideration of this idea. So normally when we talk about the change in the velocity, we talk about at that particular moment. So which means at that particular moment, the velocity changes from 5 meter per second to 12 meter per second. So in the later question, you'll be looking at, so some momentum that we are trying to discuss on will be like, for example, when a ball hit the floor and then there's a change of momentum, then after that you can see that the change in that velocity actually happened. Okay, so that's the idea. So we are not going to discuss about like the momentum change in how many time and so on, but it's just basically the change in momentum itself at that moment only. Okay, so that's the idea. All right, so let's move on to number 2. Alright, a particle of mass 2.5 kg has an initial velocity of 3 meter per second. Find the magnitude of the change in momentum of the particle if the final speed of the particle is 5 meter per second with the direction of motion unchanged. Okay, so that's the first idea. Then the part B is if, let's say, the direction of the motion reverse. Okay, so which means part B involve a change in direction, then part A is just like moving towards the same direction from the initial to the final stage. Okay, so as what we mentioned just now, the momentum will just follow the direction of the velocity. So you must make sure that you need to denote where's your positive and where's your negative. So in this case, normally we can try to denote that the final direction will be the positive one. So it will be easier for us to always get positive answer rather than negative. Okay, but there's actually nothing wrong. But I mean, don't worry about this. So the change in momentum wouldn't come out like so easy in your like past year paper. So the next chapter when we discuss about the principle of the conservation of momentum is much more easier, and that's going to be I mean the sign of the direction is going to be much more clearer in that part. Okay, so yeah, let's try to look at part A. So the final speed of the is 5 meter per second with the direction of the motion unchanged. So let's try to take if let's say this is our positive direction. Okay, so we have the u is 3, and then because of the final speed is actually moving in the same direction as well, so the v is 5. So the change in momentum is equal to 2.5 multiply the final. So same thing, if you want to do factorize also can, if you want to do it like the normal one also can. So 2.53. Okay, so when you minus off, then we have 12.5, then minus 7.5, which the change in the momentum, sorry, I should write change in momentum. Okay, it will be equal to 5 Newton second. Okay, so now B. So the final speed of the particle is 5 meter per second with the direction of motion reverse. Okay, so let's try to imagine the direction actually moves like this. Alright, so we try to take going to the left hand side as positive. But as what I say, if let's say you want to take that side as positive, that didn't give any problem as well. It's just that you have a negative answer only. So the change in momentum will be equal to, so the final velocity, if we try to take this part as positive, so which means our final velocity will be positive, right? Then is the initial velocity is moving towards the other direction, so that is negative 3. Okay, so that's why 2.5 times 5, so use the final momentum to minus off the initial momentum. Okay, so from here we can get 12.5 and then plus 7.5 is 20 Newton second. So you see how important the direction is, because that will actually give you a different answer in the magnitude. So this question only want us to find the magnitude. So no matter you are getting negative or positive, the magnitude is still 20. So imagine if you are doing in another way. So I try to use a different color here. So if let's say you are doing like going this side as positive, okay, then what you will get is your v will be negative 5, right? Then after that your u will be 3. So when you try to solve it, then you will get 2.5 negative 5 minus of 2.53. So you are still getting negative 12.5 minus of 7.5, and that will give us negative 20 Newton second. So it's actually just the same thing. Okay, so yeah, what is more important is that you must make sure that if let's say the direction of the motion change, right, then the answer that you have is actually going to be different, because one of your velocity will become negative already. Okay, so that's why it's important for you to denote where's your positive direction and where's your negative direction. Okay, so question 3. Okay, a ball of mass 50 grams hits the ground with speed 10 meter per second. So which means if let's say this is the ground, okay, so the ball actually like maybe it's here, then it hits the ground here, so which is the 10 meter per second. Then after that it rebounds with a speed of 6 meter per second. Okay, so you see how come the velocity actually changes is because of the contact with the floor, right? So find the change in momentum that occurs in the bounce. Okay, so that's why you can see that obviously there's a change in direction involved. So it depends on you whether which direction you want to put it as positive. But like what I said, normally we try to put the final position, I mean the final direction as positive. Okay, so we try to straight away get a positive change in momentum rather than a negative one. So that's why in this case, then what we have here is the change in momentum, okay, will be equal to the mass and then v minus u. So since going up is positive, meaning our final velocity 6 is positive, okay? And then after that, minus our u here is going to be negative direction than our direction that we try to denote, right? So that's why it's negative 10. Okay, sorry, I didn't put in my mass. So it's 0.05. Okay, so from here, after I solve it, then I'll be able to get 0.05, then multiply 16, which will actually give me 0.8 Newton second. Okay, so the same thing, let's try to do if let's say I try to do the other side if going down as positive. Okay, so my change in P will actually become my mass, which is 0.05. Okay, and then the final velocity is in the opposite direction, right? So that's why it's negative 6. So this is going to be positive direction, so minus of positive 10. Okay, so from here then you'll get 0.05 times negative 16, which will give you 0.8 as well, but it's negative. Okay, so the magnitude of the change in momentum is actually the same, which is 0.8, but this two thing actually indicate different thing. So the first one is that if let's say going up as positive, right? So which means there's a gain in your momentum because this is positive. So if let's say this is negative, which means there's a loss in your momentum. Okay. So that's the idea on how you are going to look at it. But normally if this question come out in your exercise and so on, and they just want you to find the change in momentum, then both of them can be accepted. But the idea is you must write down what is your positive direction. But I will always encourage you to do the first one, which try to denote your final direction as the positive direction. So it will actually makes you to easier to deal with this rather than this, because sometimes it will be pretty confusing if you have too much of negative sign there. Okay, so let's move on to number 4. All right, question 4. A girl throws a ball of mass 0.06 kg vertically upwards with initial speed of 20 meter per second. So that's this ball. Okay, so it's thrown up vertically upwards with initial velocity 20. So calculate the change of the momentum of the ball when it's at the top of its flight. So meaning maybe it flies like this, then it drops down, right? So which means we need to find what's the final velocity here. So we know that if let's say this ball reaches its maximum height, the final velocity is actually just equals to 0. Okay, so let's try to denote if let's say going down as positive, then the change in the momentum will just be equal to the mass. Okay, final velocity is 0, and then we are going to minus off the negative, right? So minus of negative 20. Okay, final minus the initial, and then the initial is actually in negative direction than the direction that we try to denote here. So 0.06 multiplied with 20, and from that then we are able to get 1.2 Newton second. Okay, so number 5. Alright, number 5. A ball of mass 500 gram is projected vertically upwards from ground with initial velocity 5 meter per second. So let's try to draw it. So if let's say there's a ball, okay, so it's projected vertically upwards from the ground with initial speed of 5 meter per second. So after it reaches the maximum height, the ball actually drops on a table which is 0.45 meter above the ground. So if let's say the table is here, okay, I mean, I'm not sure how to draw, but that's the idea. Okay, so 0.45 meter above the ground. So the ball actually drops on it. Okay, so neglecting the air resistance, calculate the change in the momentum. So during the whole process, so which means what we get is we need the final velocity here. So we can get the change in the momentum, right? Okay, So in this case, how are we going to do that? So you will require suvat. So which means if let's say we try to denote that going up as positive first for the suvat formula, so we have our u is equal to 5. Then the acceleration is the negative direction of our gravitational acceleration, right? Which is going to be negative 10. Then what is the other variable that we have? So you need to get your final velocity. So it's either that you have your final displacement or you have your time. So in this case, we know that it's 0.45, right? So which means that the total distance is not 0.45, but the displacement is actually 0.45. Because when you try to compare this final position with the initial position, the difference here is actually 0.45. So that's why the displacement is 0.45. And you can imagine that later when you try to solve it, you'll actually get two answers. The first one is when the ball is here, because the displacement is also 0.45, right? But you will get one positive V and one negative V because we are trying to denote that going up as positive. So that's why if let's say this is the velocity that the ball falls onto the table, then the V should be a negative value. Okay, so after we get that, then we need to find what is our final velocity. So suvat v squared equal to u squared plus 2as. So equal to u squared 2a and then s. Okay, so from here we can get 25 and minus of 10, 4 with 5, so 9. So from here then we get 16. So you can see our v is positive or negative square root 16, right? But we know that in this case, we are going to get the V when the ball drops on the table. So that's why the V should be a negative one, which is negative 4 meter per second. Okay, so after we get this, then now we can find our change in momentum. So when we try to solve for change in momentum, then you can try to change the direction of where is your positive as well, because we know that the final direction is actually going down, right? So we can try to let going down as our positive direction. So which means in this case, which means now my final velocity is going to be positive 4 and my initial velocity is going to be negative 5. So from here, the change in P will be equal to the mass 0.5. So the final velocity is 4 and then minus of the initial velocity negative 5. Okay, so 0.5 and multiply with 9. So we'll be able to get 4.5 Newton second. Okay, if you are using the same direction as positive, it doesn't matter as well. It's just that your last answer will be negative 4.5 Newton second. Okay, so now question 6. Okay, number 6, a ball of mass 300 gram is dropped onto a floor. Okay, so we can assume that it's actually dropped from rest. So this is the ball. So the U is actually 0. So it drops from a height that is 2 meter. And then when the ball hits the ground, then it rebounds, okay, to a height of 1.4 meter. So taking the direction of rebound as positive, so calculate the change in momentum when the ball hits the ground. So which means that what I am interested to know is actually the part when the ball hits the ground and what's the change in momentum. Because if let's say we are trying to find the change in momentum for the whole process, right, then eventually it will be 0. Because when the ball is here, it's actually dropped from rest. Then when it reaches its maximum height, which means after rebound to a height of 1.4, then the final velocity is actually 0 as well. So the initial momentum is 0, final momentum is 0. When you minus, you are just going to get 0. But when you try to look at this, right, then which means it's a different thing that we want to get. So let's try to assume that. So if let's say u equals to 0, then we can always get what is the velocity when the ball first reaches the ground. Am I right? Then after that, because of it hits the ground, so we cannot assume that the velocity that going up will be the same. So that's why it's because of the momentum change here. So we need to find what is the initial velocity here, so that when it rebounds, it only reach 1.4. Because if let's say the V and the U here is actually the same, then it will actually rebound and go back to the exact same location, right? But it's not. So that's why which means that the speed that it actually hits the ground and the speed that it actually rebounds is going to be different. I think that makes sense, right? Because if not, because there's going to be like air resistance or like friction and so on that involved. But we are not going to talk about the force in this case. We are only taking the kinematics into consideration here. So which means we know that at this point our final velocity is going to be zero as well. Okay, so that's our idea. So we need to get what is these two values so that we can find the change in momentum. So let's try to look at the first stage first. So which means is when the stage one, when the ball drops. Okay, so when the ball drops, we try to denote going down as positive. So that's easier. So the u is 0. So we know that the acceleration is the gravitational acceleration, right? So that's going to be 10 and the displacement is 2 meter and we want to find what's the final velocity. So v square equal to u square plus 2as. So we'll be able to get 0 square plus 2, 10, and then 2. Okay, so v square is actually 40. So v, because you can imagine that at this point the velocity is actually still moving in the same direction, right? So that's why the v should be a positive one, which is v is equal to 240 square root, 2 square root 10 then meter per second. Okay, so now let's look at the second stage, which going up as positive. Okay, so depends on you. If you want to do negative also can, it doesn't, I mean, your answer will be just the same, but you just to make sure that you know what you are finding and you know what's the sign that you are trying to denote here. So if let's say going up as positive, so which means our final velocity is 0, right? When the ball rebounds and reach the highest point, then after that, the acceleration is going to be negative 10 and then the displacement is 1 over 4. So going up as positive, so that's why no need negative here. Then we are going to get what is the initial velocity, which means what's the initial velocity when the ball actually starts to rebound, because we want to find what's the change of momentum here. So same thing, v square equal to u square plus 2as. So 0 square equal to u square plus 2a negative 10 as is 1.4. Okay, so from here then we'll be able to get u square is equal to 28. Is that all right? Yeah, so that's the idea. Then after that, we know that it's in a positive direction as well. So that's why we are getting the initial velocity here, which is actually moving in this direction already, right? So that's why in this case, our u must be a positive answer also. So u is actually equal to 28. So 7. So it's 2 square root 7. Okay, so that's what we have. Okay, so after we get this, then now we can proceed on to the change in momentum already. So you make sure that what we are finding just now is depends on the direction we put as here. So now let's try to denote our final direction is actually going up, right? Okay, so that's why our final velocity is actually 2 square root 7 and our initial velocity now will become the negative direction already. So it's negative 2 square root 10 because the question also state that they want to take the direction of the rebound as positive. So it's means going up as positive now. So let's try to solve the change in momentum. Okay, so the mass is 0.3. Final velocity is 2 square root 7 minus of negative 2 square root 10. Okay, so by solving this in your calculator and you will be able to get 3.48 Newton second in 3 significant figure. Okay, so 3.48, sorry, the writing here. Okay, 3.48 in 3SF. Alright, so yeah, I hope that you can understand this question. So basically, we are interested to know this point. Okay, let's move on to the question 7. Alright, question 7. A ball of mass 0.5 kg falls 1.8 meter vertically downwards to the ground starting from rest. Okay, so the situation is the same with question 6, but just that the question that they try to ask is different. So drops from 1.8 meter vertically downwards and starting from rest. Okay, so in a bounce, so which means the ball bounce as well, it hits the ground and rebounds. So the downwards momentum changed by 4 Newton seconds. So the change in momentum that happened when it rebounds, right? So is 4 Newton second. So find the height that the ball rises after the rebound. So which means I want to find what is the displacement here. Okay. So if let's say you want to try, then you can always try out by yourself. Then after that, you try to see what happened there. Alright, so which means that the first thing that we might need to get is what is the final velocity here, right? So which means it's going to be the initial velocity for your change in momentum. So that's why treating going down as positive. So we have the U is 0, A is 10, displacement is 1.8, and the final velocity is what we are interested to know. So V squared equal to U squared plus 2AS equal to 0 square, 2, 10, and 1.8. So from here, then we can get 1.8 times 3.6 times 10, so it's 36. So V, in this case, then it's going to be the same direction as positive direction, right? So that's why the V should be a number that's positive. So V is equal to 6 meter per second. Okay, so after we got this, then now we can actually find out what's the final velocity here. So which means what's the initial velocity when it rebounds. So we can know that when the final velocity here is 0, then we want to get what is the displacement, right? So which means now let me try to use the other color so to indicate different stage now. So when it hits the ground, the final velocity here is actually 6. So we are interested to know what is the U here so that we can use another super to find out what's our displacement. So how are we going to do that is check the change in the momentum. So the change in momentum is given 4, right? So that's why you can see it's positive. So you can imagine that what they are trying to denote is going up as positive. Because only by treating your final direction as the positive direction, then only you can get a change in momentum as positive. So that's why in this case, then what we need to find, yeah, you can use V and U 6 as well, as long as you are not confused with it, okay? Because this is going to be the after, this is going to be the before. So that's why in this case, then the M is 0.5, and what we want to know is the change when it rebounds, right? So it's the U that we want to find, that minus of the 6. Okay, sorry, minus of -6. I hope that you are not confused. So let me try to explain again. So the change in the momentum, so which mean if we were to take this as a, I mean, much proper case, then it will be the initial is actually -6 and the final is the one that we want to find. But this final is going to be the initial for your second stage. Okay, so the change in P, so M, and then after that, V is what we want to find, minus of -6, then 4. Okay, so the mass is 0.5, so we can straight away write down 0.5 here. So bring 0.5 over, then we have V plus 6 equal to 4 divided by 0.5, so that gives us 8. So V is equal to 2 meter per second. Okay, so which means this is going to be our initial velocity for our second stage. So I try to use a different color as well. Okay, so which means U is equal to, let's try to denote going up as positive. So U is 2, final velocity when it reaches the maximum height is 0, right? Then we want to get our S. Then another thing that we have is acceleration is -10. Okay, so we are interested to know what is the displacement. So which means we know that what's the height of the ball rises to when it rebounds. So UVAT, so in this case, then UVAS, so it's still V squared equal to U squared plus 2AS. Okay, so V squared 0 and then 2 square plus 2AS. Okay, so sorry, I need to write here. So 20S will be equal to 4. Okay, so from here then I can get S is equal to 0.1 over 5, so 0.2 meter. Alright, so that's what we need to find in this question. So now let's move on to the last question for the variable acceleration. Alright, question 8. A soccer ball of 450 gram is kicked and the displacement is given by s equal to 1 over 2 t cubed plus 160 over t. Okay, so you can imagine is that you have this soccer ball. Okay, so someone actually kicked the ball. So the displacement that taken by the soccer ball is actually s equal to 1 over 2 t cubed plus 160 over t. Okay, so the ball will actually just move, right? So when the ball actually moved, then what happened is that at the time for the fourth second, so there's a player of the opponent team actually kicks the ball, and then the ball now move in a 5 meter per second in the opposite direction. So the ball now moving in this direction. So the question wants us to find the change in the momentum. So basically it's at this point. So which means that if let's say there's no extra forces, I mean this player didn't kick the ball, then the ball will actually continue to move, right? So that's the part where the momentum change. Okay, so which means we will need to find what is the initial velocity first. So how are we going to get that is from the equation here. So s is equal to 1 over 2 t cubed plus 160 t. So from here then we can know that v is actually equal to ds dt, right? So I can actually solve it, then I can get 3 over 2t squared minus 160 over t squared. So after I get this, then now the time is equal to the 4 second and we want to find the v. So 3 over 2, 4 square minus of 160 over 4 square. So we can get 16 then 2, so it's 24. And then minus of 160 minus 16, so is 1, 2 is 10. So we can get 14 meter per second. Okay, so now we know that, let's try to denote that our final direction as the positive. So the change in the momentum P will be just equal to 0.45. Okay, let me try to write here 0.45, and then after that multiply with our final velocity, which is the one after kick, right? So it's 5, and then minus of initial velocity in a negative direction now, so negative 14. Okay, so we can get 0.45 then multiply with 19, and that actually gives us 8.55 Newton second. Okay, so that's pretty much of it. I hope that you can actually understand the idea on how are you going to find the momentum. Then remember that it's a vector quantity, so that's why denoting the positive direction is very important. Then for the next lesson, we're going to talk about the more important part, which is which is the principle of the conservation of this momentum, and we're going to solve the question when two particles actually collide with each other. Alright, so that's it for today's lesson. Spend some time to do your work, and yeah, I'll see you on the next lesson. Thank you.